Hello, everyone. Welcome to another episode of the Day Zero podcast. I'm Spectre. With me is Z. We have a few topics to get into today, but before that, I know that Z wanted to talk a little bit about our topic coverage, so I'll let him jump in here, and then we'll get into topics.
Yeah, so we've had a lot of focus on exploits, on the exploit development, on cool bugs and cool exploits. I would like to see if we can get some episodes going talking a lot more about discovery vulnerabilities, doing vulnerability research and such. And part of that is like those sort of posts. We've actually got a couple on this episode, but those sort of posts tend to be kind of rare. So I was hoping, if anybody's got any favorites, from basically all time, feel free to send them our way, drop a comment or DM. We've got an interesting links channel in the Discord too. Just drop the links to those so I can take a look if anybody's got some good content on, finding bugs, on methodology, on, the discovery tactics. Not super interested in just tips and tricks. Not super interested on that because those tend to be very one-off, but talking about research and methodology and stuff, because I'd like to maybe get a couple episodes in where we have a bit more of that sort of focus. So yeah, if you've got anything to share, let us know. Share the link. If not, well, hopefully we'll be able to put out some good episode on, or find some good links for a good episode on that.
Yeah, for sure. All right, so we'll kick off our discussion with the hotness right now, which is AI. So ZeroPath put out a post on autonomous discovery of critical zero days, and it involves leveraging large language models and some algorithms and stuff from that area. Now, this is kind of an interesting area where there's a lot of grifting going on right now with large language models and security. It feels like there's like 100 companies every other day that spring up that are talking about using LLMs for security, and a lot of it is straight up just nonsense. But this is one of those rare posts where it actually does seem like it has some water to it and could actually be useful for covering some of the weaknesses of classic static analysis. So I'll let Z get into it.
Yeah, so emphasis definitely on that could be useful because this is a product, this is definitely a marketing post. Trying to market to a more technical audience,
Definitely.
so we do get that. But there's also, we don't get a lot of information on some of the deeper details either, especially on how they're really leveraging. But you have enough information here that I think if somebody wanted to start looking at trying to apply an LLM into vulnerability discovery, I think you'd be able to take some of these ideas and actually do so. And kind of shows where the differences are between, I think, what a lot of people who aren't trying to do any research with LLMs and do VR, have it find or call out bugs for you, might imagine that you're just pasting some code or giving ChatGPT your code file, asking it, tell me all the vulnerabilities in here, and then getting kind of nonsense back out. Whereas they definitely have more of a process involved here. So what they talk about is their technical methodology. Starts off with them talking about how they're using the LLM to kind of do some application identification. So just in a code base, they're going to try and split it up, find microservices, find whatever, find routing, whatever. They're doing that. They don't include a lot about how they're doing that. They're just, specifically, we do this thing, identify, directory boundaries and all of that, which, fair enough. Usually you kind of can see some sort of structure in the code, see the references and figure things out there. But then when it comes to their stage 2 is where things I think are going to kind of split off from what you might expect using an LLM looks like into what they're actually doing and the complexity that comes into trying to use an LLM to find vulnerabilities. Namely, their next step isn't give this source code to an LLM. Their next step is generating an abstract syntax tree. So taking this code, taking it into a more computer consumable-ish format. They talk about using Tree Sitter here to do this conversion, specifically with a Django application, a Python application, but would work on other things too. They generate that AST, they generate a call graph, they do enrichment of that call graph to include some, in this case with the web app, that's going to include things like HTTP methods and kind of routing and all that enrichment information. Then finally, they're going to come into, now we're doing our vulnerability discovery, where they're actually going to try and use the LLMs to discover that. and they call out a few specific algorithms that are not really algorithms, but techniques that they're using. First of all, I'll talk about really quickly. There's the React framework. That's kind of your prompting framework. And nice thing here is they do link off to the papers that are relevant to this. So like the paper that introduced the React framework that is provided as a link, so you can actually take a look at the paper. Same deal with Tree of Thought. Just pulling these up here so we get the links. That said, because LLMs are, and this sort of thing is, a big buzz right now, a lot of hype around it. There's also a lot of YouTube videos out there that do explain these things and do give you at least a high level overview. Several people even go into explaining the papers, so there's some really good content out there that gets into this. But the main thing there is with Tree of Thought, basically, what you've got is, instead of just asking like in one single prompt for, hey, LLM, act as a vulnerability researcher, do a security analysis on this code and find all, like, instead of doing something like that, you kind of create a tree of thought. You're allowing the LLM to kind of create a state, or like create basically nodes in the tree and follow its thought process along, so the LLM can actually like backtrack through its own thought process. And if you've worked with ChatGPT's or OpenAI, I guess technically OpenAI's O1 model preview that's been out for a little while now, notice how it kind of has its chain of thought thing going on there. Some people have argued that this is we don't have access to the actual chain of thought that's going on, so we don't know the details of it. But definitely some arguments going on that what's going on with that is that it's just implementing this tree of thought process and allowing the AI to kind of direct itself in terms of how it's going. So as far as I understand tree of thought, like, that's, if you understand kind of how OpenAI's O1 model is doing its reasoning, it's kind of applying that sort of idea. The React thing is just a framework for prompting the reasoning in action. React being kind of the name of it, but you can kind of give thought, action, observation. It's a way of actually writing out part of writing out the prompts, having it know, like, to ask for an agent to do some action, or call out on that. And you'll be able to dig into all of these. And the last thing they call out is like the Monte Carlo tree search, kind of a established algorithm. I do want to be clear here, I'm definitely not an LLM expert, so I am kind of explaining these at a high level, but dig into it if you actually want the specifics. Don't trust my explanations here of everything. But self-refining is basically letting the LLM refine its own, both, like, the simplest example, like the first kind of self-refined algorithm was just like, give it the prompt, get the output, ask for the LLM to give its opinion or like fixes or refinement on the output, and then use that for it to generate like a new prompt, and like you loop that and have it self-refine. Monte Carlo just has a navigating more from Monte Carlo tree, has kind of ways difference between exploring kind of successful answers versus unsuccessful answers that might still produce a decent prompt, versus just going for the good answer and following that route. Has a bit of that going on. So basically what I'm getting at is there's a lot more to trying to find the vulnerabilities and doing so successfully than just asking an LLM to be like, give me all the vulnerabilities, please, which I think for people who aren't using LLMs is a common misunderstanding, is like, well, I've used the LLMs, it hallucinates, it does this, it's not good for this at all. And these sort of methods, like the self-refinement here, the Monte Carlo tree, because that's working off the answers, it's scoring answers, it's doing a bit of work there, helps kind of fight against some of the hallucinations, because it kind of needs to be consistent, so hallucinations tend to show up as more one-off. Actually, a lot of these things in practice do also, like having the tree of thought. Again, you're doing multiple prompts here. A lot of this adds up to improving the results and giving a bit more confidence on that, and then you can tie this in with agents to try and do more verification. But ultimately, while this post kind of leaves a lot of these details out, they're just like, yeah, we do this thing, and like, here's how we're different. It does give you enough information, I think, to kind of get started if you wanted to. Like I said, it links out these papers. links out all this information that if you want to start looking at this I think would be a decent starting place. Again, I'm definitely not an expert on this, so this is kind of the first post that's come across my desk that I felt like actually got into some of this stuff or mentioned enough to help you get started. Uh, but it's very well possible that there's a lot of people talking about that, and I'm just not seeing it. So I don't want to make the claims like it's all novel here, but I think this does give an idea of the process that you can put into it if you want to start trying to adapt an LLM into the vulnerability research.
I mean, the problem with LLM stuff is the signal to noise ratio is very high. So I see tons of LLM stuff with regards to security that comes across my notice. The problem is pretty much all of it is junk, right? Which is why I did kind of like this post, in that it highlights some of the actual problems you run into with conventional tooling and how they're trying to solve that. For example, when I was introducing the topic, I was talking a little bit about static analysis. And one of the big problems you have with static analysis that they call out is the amount of false positives and things that you can have come up, because if you try to go too deep on it, you can run into state explosion problems very easily. Like if you're trying to do like symbolic execution and things like that. If you don't use stuff like that, then you're missing context that, it could think something's a vuln when it's intended and it's known not to be a vulnerability. So that's kind of where they talk about using things like the Monte Carlo tree search to actually validate issues and check against their like threat modeling. And maybe it's not perfect, but if it comes out that it can do a little bit better than static analysis and kind of augment it, then that's pretty cool. And like you said, we don't have all the details, but at least that approach and some of the ideas that are being talked about here are interesting to think about. So that's why I like to post.
Yeah, there's just enough details here that feels like if you wanted to dig into this, you'd have the information you needed. Like you can nothing in here. It doesn't feel like they're hiding kind of their secret sauce in a sense, like their specifics, but they're giving you the high level view here. So yeah, that's why I like this. Did remind me there's actually a training coming up, just a virtual training from the guys at Absolute AppSec. So I'm just going to give that a really quick shout out. Harnessing LLMs for application security. I've been listening to the Absolute AppSec podcast for a while. I've talked about it a few times in the past year. They've had this practical secure code review course for a while, and they added AI content into that. And it sounds like now they've just had so much AI stuff that they want to be able to talk about that you can't fit into that training. So they've actually put out their own training here. It's $1,200. This is literally going to be days after this comes out, November 7th. Presumably they'll run this more often, but yeah, they're doing a training. It's new, and I have nothing but respect for the two guys who host the podcast. They definitely know what they're talking about. It is a little bit wider than just for vulnerabilities. It is for application security on the whole, so they do go more on threat modeling and stuff, but still I expect that to be a pretty solid course from them. So just a really quick shout out on that.
All right, so yeah, I think we can move on to our next topic here. So next out of GitHub Security Blog, we have post on attacking browser extensions with the help of CodeQL, because it's actually been a while since we've covered a GitHub security post that talks about CodeQL, but they're fairly common. They like own it now and everything, and they're taking full advantage of it.
Yeah, I see CodeQL and I add the post. Actually, in fairness, I added this post before I even saw it had CodeQL in it, because I usually add posts just saying, oh, that sounds interesting to check later. So it didn't actually lead into it, but I love seeing it. I am a big fan of using CodeQL. It's the one security analysis tool that feels like it lets the researcher be in the loop. It's not just find the bug, but it's just generic. Anyway, go ahead and keep talking.
We are big CodeQL shills, so or you are at least.
Yeah.
You talk about it more than I do. But yeah. All right. So yeah, so this is a post on browser extension security. A big chunk of it talks about the attack surface of extensions and some important background, because they are a little bit unique in terms of how their like input model and stuff is. So the first major thing it talks about is the three major contexts that you have. So with extensions, you have like content scripts that's operating on like the page contents. You have background scripts and pop-ups, with background being the most powerful with the most access to the web extension and browser extension APIs. Now, of course, with how powerful some of these APIs are, they are permission gated. So extensions come with like a manifest file which notes what permissions they are requesting, and when you go to install that, Chrome or Firefox or whatever will kind of prompt you like saying, okay, are you okay with the extension having access to these things? Some of the really big ones are things like cookies, bookmarks, or things like the active tab. So with extensions, the security contexts that are important are the more obvious one, which is like malicious extensions. If you install a malicious extension, how it could abuse its functionality. But the more interesting one that's talked about more here is the ability to hijack a legitimate extension. So, for example, you could have a legit extension that rewrites page content to make it more accessible or something. And if that extension processes that page content in an unsafe way, if the attacker can control some of that content, that could be leveraged to get the extension to essentially inject like an XSS or something like that. And of course, you have the ability to send and receive messages through send message, and extensions can set up handlers to handle all that. We've talked a little bit about message handling in JavaScript before and how hard it can be. Even like Meta or Facebook has had issues with these sorts of bugs. And again, depending on how the manifest is set up, a malicious extension or even just a malicious website could potentially send messages to the extension handler. And depending on what that handler does and how well it checks the message origin, that's another big attack surface, especially if you can get some attacker controlled input into a powerful API sync like execute script. And that's kind of where it tails off into.
So one of the things you mentioned is how you have like the main context, the background script being the most powerful, and like content script. I'd kind of argue like they're both powerful in their own way. So the background script cannot access the content of any page. The content script is what you gets injected into any page it's allowed to run on. So when you have these extensions that use like all URLs or just use wildcard or something, they'll have like a script that is injected onto every single web page, and that the idea is that script will then use like send message, post message to send a message back up that the extension will then see, validate it came from the extension, and then handle. So you kind of have the exact same sort of situation as you do with a lot of just cross-site messaging bugs, where you might have an iframe that's communicating using post messages. Like you have exactly the same sorts of issues where maybe there's a lack of origin checking or anything like that. But yeah, I guess the point of me interrupting for I go too deep on another topic was just those two, like the background script and the content script, all kind of work together to communicate. You need the content script to actually have access to some of the information on the page. You use the background script more as like management. It has access to like the browser. It can communicate with, say, an external service or something, like, if it has installed things, so you can get like RCE out of it. But the communication option, like extensions are built off of web technology. So I don't know. I thought this was a nice little post because you do get some background information, and it's just one of those things where I know a lot of people kind of see like, oh, there is a browser extension included in the scope for a bug bounty, but then don't really start looking at the browser extension because, like, what do you do? What's here? And you do get a bit of that information out of this post, and like it is just built off that same web technology that you've probably already dealt with on bug bounties. You just didn't realize it, perhaps. I mean, maybe you didn't realize it. That's also possible. But so yeah, that was one of the reasons why I wanted to kind of include this post. It wasn't even so much about the code QL, because the code QL query isn't that interesting. It is just looking for, that execute script sync. But yeah, just coming from just showing kind of what an extension looks like, and it's all just JavaScript really going on here. So you've got a lot of those same sorts of issues. XSS can happen in the extension just like it can happen anywhere else. In fact, sometimes even more likely to happen in an extension because they're more likely to not be using a framework for all of their UI because it's a little bit weird inside of an extension. So you're not supposed to like dynamically load scripts in your extension. You can vendor them, you can bring them in, so like totally gets used, but it is a little bit different, a little bit weird. And so you can see some of those bugs, and it's kind of an escalation point.
Yeah, and again, I haven't really gone out looking for specific resources to cover like attacking browser extensions too well, but as per usual with the GitHub Security Blog, this post at least does a really good job summarizing it and getting into all the background. So if extensions are something that sounds interesting to you and you're not super familiar with it, this post is definitely something to read and recommend for that.
Yeah, it's a good little introduction to just a simple bug. And the bug itself, for what's worth, what they found here is just basically this application will take a message handler or has a message handler, doesn't really do any checking on it from the message itself, calls this su.apps, and then just creates this code using message.app type. And it's injecting this, using execute script. So Chrome tab, execute script, injecting that right in on document start to whatever tab. So basically, you can you could easily break out of, like, provide any app type, break out of that JavaScript, inject your own JavaScript that's going to be executed on whatever frame this is calling into. So cross-site scripting through it. Another route for cross-site scripting that I don't have actual stats on how often people are looking at the browser extensions, but in talking to people, I've definitely seen it come up where a lot of people just don't really know how to start approaching it. So yeah, good post out from GitHub.
It's something I'm a little surprised you don't see more of because like I was actually reminded of a quote from the Hardware.io keynote, where they basically talked about the fact that the browser is like the single most important thing security wise nowadays. Pretty much anything that's important that's going on is going to be done through the browser, and like extensions are really really powerful, and a lot of people will just install them without really thinking too much about the implications or like what they can actually do. So the impact of being able to like compromise or install a malicious extension is extremely high. So it seems a little bit disproportionate of like how much research is out there about them compared to how much the impact is. Maybe that's just you know, our
So
limited visibility, but
part of that, I think, has to do with the extension stores are a little bit of a walled garden. People are
they
installing
do
them.
vet them. Yeah.
They do vet them a bit. Like the vetting isn't necessarily that great. There have definitely been malicious extensions, but like the core extensions that a lot of people install tend to kind of also be very popular, have had people already looking at them. So I think that's kind of what's going on, where people aren't really thinking about, because you kind of have the vetted, you kind of have like, like if something isn't super popular, it's more risky and you're going to have some second thoughts. Whereas like, uBlock Origin or something, maybe a little bit less concerned about just installing that, even though it can do a lot. But yeah, I don't know. Just it does feel like maybe the risks of it aren't well understood. Also, is maybe another thing.
Yeah. All right, so getting into our controversial topic of the week, we have what are my options? CyberPanel Pre-Auth RCE. So this talks about a Pre-Auth RCE in CyberPanel, which is a Django web app with a bunch of APIs. Basically, it seems like CyberPanel's whole design is pretty decentralized. You have a lot of like different functionality that's added, all these different API routes, and the authentication on that is not centralized very well. Each endpoint kind of has to do its own auth checking. And of course, getting into this vulnerability, there was a new functionality that was added. It was called upgrade MySQL
So
status.
sorry, just
What it
before
really
you
does.
dive into all of that, I did
Yeah.
really quickly just want to talk about the type of application this is, which
Okay, go ahead.
is like CyberPanel is kind of in the same realm as something like cPanel. Maybe you're familiar with that, maybe not. I do feel like cPanel has definitely dropped out of like being something people talk about. It's one of these panels that like a VPS provider, maybe they'll provide like a reseller box. Somebody can buy a box from them and then they can resell it off to their friends and give their friends like this slightly more limited account that lets them do things like change their PHP version, or, you know, give them like a file upload interface, or set up FTP accounts, whatever. It's meant to kind of make like running a server easier. And a lot of these panels end up being run by people who don't really understand how to manage their own VPS, because that's why they're using the panel in the first place, is because they don't really know, but they heard this is like a money maker or something to just resell the box. Because you buy a really powerful box, you resell it to your friends, you give them a little nicety there, and you get to charge a premium and you take a cut of it. So that's kind of the space that this application runs in, is really powerful. Like, it is a trusted interface. This is something that, like, well, it's a semi-trusted, so it can be really trusted. It also can be very much not trusted. A lot of these panels don't get very well looked at. Like, they're just random piece of code somebody wrote to make it easier, shared it, and then got some adoption. Like, don't have strong teams behind them, and that feels kind of like
they're not super mature code bases.
Yeah, like they might be around for a while, but yeah, they don't have like the maturity of a well-developed thing. That has been my experience with a lot of these panels. Like, just on given their audience and the type of people using them, they don't tend to be the thing that people necessarily look at super hard. They should be, but they don't. That's at least been my experience with them. Obviously, that can vary, so whatever. I don't want to hate on all panels or something, but it is a thing that
back in my day we set up our private servers with command line.
Oh no, I think these panels were more popular back in the day, actually, because there's a lot more people
just about to say that. So it's good you got into the context there. I kind of just skipped over it, but I was gonna say, like, like you talking about cPanel was really what clicked the light on for me. I remember seeing this a lot back in like the late 2000s, like early 2010s. I remember seeing a lot of like rehost VPS services and all that kind of stuff, and seeing like cPanel and these kinds of panels you're talking about. And I kind of totally forgot about them over the last like 5 or 6 years or something, because I'm just not really seeing them anymore. I don't know if that's just because I'm just not really looking at those kinds of things anymore, but it seemed like they kind of disappeared in favor of like a lot of the cloud stuff. Exactly. Yeah. So yeah, I mean, it's sort of a throwback, I guess, in a way too.
Yeah, no, it's definitely a thing that I don't think is anywhere near as popular now. Like, cloud has, using all the different cloud services, and just like a VPS, having your own VPS rather than sharing a server is way more common now than it used to be. Where, you know, my first hosting that I got when I was a kid, like, was just on a shared server, probably even ran cPanel, to be honest. I don't remember for sure, but I'm like 90% sure it was cPanel. And it was like, you know, you had like 50 people all on like the same thing. Like, there was no real isolation. There was user isolation, but like there wasn't much
like
strong
resource
security.
Isolation or anything.
Yeah. Which there wasn't much option for that, because unless you were going to run like a VM, didn't have like containers yet.
Yeah. So yeah, getting into the vulnerability they're talking about here. So there was a recent functionality that was added called Upgrade MySQL Status. What it does isn't really too important. What is important is that the function would take the input in the form of the status file from the request data, and it would straight up just like concat that into a command string that gets executed. So
into a pseudo command string. Yeah,
a pseudo command string. Yeah, even better. So fairly straightforward command injection. And this function doesn't have any authentication checks, which is why you could just reach it pre-auth. Now, there was a little bit of complexity to actually exploiting this. There was like a firewall sort of called sec middleware, which would strip common injection characters like pipes and semicolons, ampersands, all that kind of stuff. The problem with that, though, was that this middleware would only actually like intercept and strip post requests. And the endpoint that was vulnerable could be reached through other request types, even if they aren't necessarily supposed to have request bodies. because the endpoint code read the request body and not like specifically checked if it was a post request and read the post body, you could send like options or patch requests or something like that and reach this code and just straight up get to command injection as sudo. So pretty straightforward exploit, not a ton to talk about there. But there was a little bit of controversy around this because this bug was reported and it was fixed on the 23rd of October. And the author had then asked the vendor if it was okay to disclose. And the vendor had said, yep, that's fine. Just wait a few days so people can upgrade. So they did. And then on the 27th, this post was published. And it seems a lot of different places had not updated the CyberPanel yet. And so there was like a ransomware attack wave that was launched that leveraged this issue. So there's a little bit of controversy there, kind of coming back to the same old disclosure discussion. Although in this case, the vendor had given the okay and did not, like, they asked for a few days and a few days was given. So sort of an interesting case, I guess. I'll let you give your thoughts on it, see.
Yeah, so I do have a few thoughts here that I'll carry on with this, but I also have some thoughts about the actual bug that I want to get to also. When it comes to the disclosure, so yeah, it was basically like they did that on the 27th, I think was the disclosure. And then like 2 days later on the 29th, the ransomware attack. Very straightforward bug. And part of why I include that context about like the panel and the people running it not necessarily being the most savvy is, updates aren't necessarily a high priority for those people. They're not necessarily paying attention. These aren't necessarily well-managed servers if they're also, needing to use some of these control panels rather than kind of understanding how to just do that in the command line. Not to, like, say there's no place for the panels, but it speaks to a certain audience, I guess is the way I'd put it. When it comes to the actual disclosure here, I mean, they had permission. There's no blame on the research here. And in fairness, I don't think there's any blame really on CyberPanel for being like, yeah, go ahead and publish this. I appreciate the fact they are. The only thing I'd say is, maybe a little bit more knowledge. I mean, I'm sure Dreyant here, the researcher, is going to take a lesson from this about, how things can be abused, how people might end up running with these vulnerabilities and like basically that patch gap, the difference between a patch being available and the patch actually being deployed. When it comes to the actual policy on disclosure, something I want to shout out here is that a lot of people are aware of like the 90-day disclosure. So that is like I feel like Project Zero really popularized this, although they weren't the first ones.
I'm pretty sure.
They weren't the first to do 90 days. But like people know about Project Zero, they know about Google, and so a lot of people are familiar, with Project Zero's 90-day disclosure, and I feel like they're the ones that kind of popularized the 90 days as being like a pretty standard thing. I know MITRE actually only uses like 30 days on their policy, like 30 days after you've done that, they go ahead and disclose. And thing is, Project Zero's actual disclosure policy, at least the last time they did one of their posts on like our policy, which they did yearly for a very brief while, and then they stopped. They kind of refer to this as they follow a 90+30 disclosure policy, and this is something I've really liked. So the way they run this, and so there is the Google-wide policy, and that is just a 90-day disclosure policy. 90+30 makes a lot of sense, especially with Project Zero dealing a lot more with kind of external teams, is that if a vendor they've been notified about a vulnerability, they have 90 days before it's just fully disclosed, but they will disclose, so either 90 days and get disclosed if there's like nothing happening, but if there is a patch available, it is 30 days from the patch. So if that patch comes out on day 7, it's day 37 where they'll disclose the vulnerability. If the patch comes out on day 89, then it's another 30 days from there when they do the disclosure. Or they have the example here, they issue the patch 83 days after, then comes out on day 113. So it kind of even goes beyond that 90 day, and they talk about their grace period here. But it's that +30 that's kind of important. It gives time to patch while also like not necessarily just waiting forever for a patch to come out. Like they do have that risk there. This is going to be disclosed and it does get shared. So I did want to shout out that part of the policy because I think that is missed a lot. Like people just go 90 days, then you can disclose 90 days. Whereas, it is a little bit more nuanced. There is this 30-day point to it also, at least in this posting. Their vulnerability disclosure really just talks about the 90-day aspect, and then just 30 days after the fix, they don't use this 90 plus 30 notation. But yeah, I think it's an important distinction because the gap between patching and like the patch being available and systems being patched varies quite a bit, especially on a panel like this. It's going to actually take a while, I think, for a lot of patches, even if this were delayed. Unless the CyberPanel actually has an automatic update system, which I'm not sure about, I would expect a lot of systems just wouldn't necessarily be updated. Although they do mention that this was a new feature that was added, so maybe they are auto-updating, and for whatever reason, some of these just didn't or weren't, but we're on that one update, or we're on the update that had this.
So on the P0 stuff, I did just want to ask, was the 90 plus 30 a later addendum that they did? Because I remember when we covered on the podcast when P0 had actually updated their disclosure policy, or I should say Google updated their disclosure policy, because they left it as their like typical 90-day one for a while until like a couple years ago where they had made some changes. Was that one of the changes, or has it always been 90 plus 30 for?
So I'd probably have to go and take a look at some of their past things about their disclosure policies.
I'm just trying to remember
let me
what
open a random
changes were.
The 90 plus 30 was explicitly mentioned on like as far as I know, the last one that I saw.
I'd have to like rep my notes, which I can't do very easily anymore.
Actually, so it looks like the year before that, in 2021, that seems like that might be when they added the 30-day.
That's what 30-day
period.
I remember us
talking about it. Patch. Yeah.
Right. Yeah.
It started as just full 90, and then 90 plus 30 in 2021.
So that's kind of why that part of it isn't really like well known about or talked about, I guess, is because it came a bit later. Good. And it's always harder to push that.
Good shout, because I forgot that was changed. In my head, that's just what it's always been, because we've actually kind of followed the updates as it came. But good shout. And that would explain why it's less known, but that is an aspect, and I think it is an important aspect of disclosure, is to give that time to patch. Fortunately, this is the sort of thing that can happen, but at the same time, I totally get why. Like, if you're not really thinking about a lot of this, because this is more of like an AppSec sort of thing. Like, how long does it take to patch? Like, it's not really something you're thinking about as, even a lot of pen testers, bug bounty hunters, like, you're maybe not thinking too much about, you, or you might be thinking about only in the sense of like, can I get a bounty if I report this, and like, that sort of sense, like how quickly are they going to patch this versus report it. Anyway, there's kind of that aspect, but not really thinking about the disclosure process necessarily as much.
Yeah, I mean, I was just going to jump in and say the author had straight up said, hacking has become such a gamified experience for me that I had no idea about this potentially being used by threat actors. And, that's totally fair.
It is,
I don't think it's, I don't think people should be dogpiling the research or anything for having to consider all that. Like, that's not.
They had permission, so definitely not. But exactly. Even dogpiling like CyberPanel.
CyberPanel, even that's not totally fair.
Like, I mean, I would expect, maybe someone like Microsoft to have really been thinking about this and be aware. But a random company, like, I don't know. It just feels like a thing that until you've actually either you're aware of it through like you've done threat analysis and like kind of know how threat actors work and like how these things are actually utilized and people do look for those patch gaps. Unless you're kind of in that realm, the thought really probably isn't going to cross your mind. Like, it's really obvious after the fact, but before you've had that exposure, exactly. Before you've had that, like, it's so easy to just not really be aware of. Like, it feels super obvious, but you're not thinking as like that sort of attacker. Like, that is a very different mindset. I think that a lot, like, I mean, hacking is thinking like an attacker in many ways, but that is a different aspect to it that a lot of people aren't aren't thinking of and don't really need to. So yeah, no, definitely no fault, I think, on the researcher or CyberPanel for that. It's one of those things they've learned their lesson though, hopefully. I just hope CyberPanel doesn't take the response as like, no, you can never disclose vulnerabilities now, because that is not the right response.
That would really suck if that was the takeaway. So yeah, hopefully it's not. But
Oh,
yeah, it is sort of interesting too, though, because like this issue of patch gapping, you don't see super often in web. Like typically with web, like a lot of the issues that we cover, it's affecting a singular thing, or even if it's affecting a framework, like the security advisory system and everything that's set up is kind of good for preventing a lot of patch gapping stuff. A lot of where I see patch gapping, at least, or it being talked about a lot more, is on like devices, especially like IoT, because it's really hard to update IoT devices. And even like the update mechanisms themselves are usually like attack vectors. But yeah, you don't see it too often on web. But this is an instance where it kind of makes sense that it happens, as you were getting into earlier.
yeah, and I part of that is like, because you would maybe see it if there was like an open SSH bug, something really core like that a lot of servers are running. Wouldn't necessarily see it with the web. Yeah, that's a really good point. I hadn't even thought about that aspect of this one actually. So not much to add there. Though I do want to comment a little bit about the bug. I do also
Yep.
want to send a little bit of hate. They this bug they found it using semgrep and not CodeQL. So I mean,
Oh,
got
how
it.
dare they?
Yeah, I mean, got to really stand. No, actually, semgrep. It actually. I'll even mention with the last post we talked about, where they're just looking for that sync. That's actually, I think, a way better thing to just write in semgrep. Way quicker to do. Semgrep is almost certainly going to be sufficient for that in a lot of cases. Semgrep is more of a lexical analysis, so you give it the pattern to match. It has some semantic understanding, less semantic grep. Has a little bit like understanding of code and data flow. Not super deep, but super quick and easy to write. CodeQL is really annoying to learn to write. Semgrep is awesome. Semgrep, works pretty well in this case. So, not actually any hate on that front. When it comes to the code, like I just want to shout out because we used to talk about like code smells and stuff. Reading through the code, one of the steps that they took early on was okay, they have to do a pen test on this product. So, first step, take a look at what existing research is out there. What are the existing exploits that have been published, bugs, whatever, any sort of documentation. Look at that information. Definitely a good first step, what you should be doing. And then when you go there, you start seeing like this a very ad hoc authentication mechanism where every single function needs to remember to do it. And when every single function needs to remember to do their own authentication and like do everything, it becomes really easy to just forget that somewhere along the way. So it's a lot better, especially because they have middleware support here to like put some routes behind their auth check middleware that's like this one checks if you're an admin, this one does this, and have like some standard behind that. They also mentioned being able to just pass in like a user ID equals one parameter and get around some of the checks elsewhere. They don't show any of the code there. I didn't dig into it, and I think the case that we or one of the specific pieces of code they show us uses session, so you wouldn't just get to pass that in, but or maybe it gets added to the session from URL. I don't know, but yeah, definitely kind of a code smell when you see that because things get missed. Like humans forget all the time. Inspector touched on this when he talked about like centralized versus decentralized, like just the security. I am a fan of seeing security mechanisms be centralized in an application because that way, like they're applied, by default, they exist, and you can usually, see how they're configured and like what's going through, what's not, or what's using what very easily. Um, Instead of needing to look at every function, you could be like, oh, this thing doesn't, fit into any of these. Why is that, or whatever. The other code smell probably going to be pretty opposite is just the fact they use these like this process utilities output executioner or yeah, executioner. Just that they make all of these like actual command calls. Like
Very
one of
lazy.
yeah, like one of these checks here, like one of their attacks to be like, okay, we got to make sure they're not like running any sort of attack against us. They have a few like command injection attack, which I love because they've got a command injection check after the command injection happens. Like they've already run commands using input. And in this case, this was the command that was vulnerable, like this call to ls-la with the data complete path. And they execute that, and like it has the vulnerability. But what they're doing with it is like they're calling the LSLA to check if there is the arrow, well, a couple characters, but to see if that is in there so they can detect that there is a symlink attack going on. So like it's just like the fact that they do this all the time, like they have a lot of calls to that, is a huge red flag for any application. But especially also like parsing the text of it and like doing this sort of analysis. Like there's a lot of bugs that can happen when you're just looking at the text and trying to match it like that. Like a lot of sort of output injection attacks can come from that, which is a fun class actually to keep in mind. But yeah, this
you can
is
have
just
like 1,000 variants with this code pattern. Like
yeah, like a lot
problem.
of systems. There's a lot of ways you can get output going. Yeah, it's one of those code smells. I'd hope a lot of people would pick up on that. Like whenever you see a lot of commands going on, like that is just a bad sign in general.
Yeah, and I'll say too, if your application is building up pseudo commands to do stuff, it probably needs to be rewritten.
That's a good point. Yeah, the fact they're doing sudo with that, which means it's passwordless sudo. Yeah, there's problems here. There are red flags going off. The bug that they actually found here to bypass, like I guess not the bug, but the bypass of the middleware, super common issue actually. So worth keeping in mind.
I think we talked about it before.
We've
leveraging
covered
different
this.
HTTP methods.
Yeah, we've covered it a lot. Because one, GET requests, you can include a body in a GET request. It's not to spec, but a lot of systems will accept it. Option obviously is what they did here. Head is another one that, especially head and options, actually both tend to get passed through a lot, so they can get the right header responses. Well, for head, they want the header responses, but options may be a little bit different, and options can sometimes get captured by middleware. But yeah, a lot of systems will, like, they'll register the route universally, especially if they want to capture like get and post, and not necessarily think about kind of the rest that you can send. Like you can't do remote attack like cross-site scripting on anything with get and post, but you can still use those verbs. It's a really common pattern to see where checks get enforced only against like certain verbs. Serve checks are another common one. I guess that's going to be less useful now with same site, but it is a thing that would get checked in like these if it's post. So send something else. So if you can sneak it into a get. Other thing I'll just mention, not the case here. Method overriding. A lot of frameworks have some format for that. Maybe it's including a URL parameter, like underscore method to change what method it treats it as. That's another way that you can kind of get around some of these.
All right. So getting into our shoutouts of the episode. So Apple put out a new bug bounty program on their private cloud compute, which is something they launched somewhat recently. They also would put out the source code for private cloud compute on GitHub so that security researchers can audit it and whatnot. So I believe private cloud compute is mainly used for like LLMs and securing the models and everything. So there is a bit of that aspect to it as well.
I think that is how they're implementing it, but I don't think
it's not super relevant for actually auditing PCC.
Yeah, like that just happens to be the stack that they're running on it. So we talked about like the attestation stuff before when we were talking about like the Intel SGX. It's kind of got some of that going on where they want to be able to attest that this code is running there. They want to be able to say like this is actually this code running on whatever, and like have that sort of privacy going on. This code is actually doing encryption, things are encrypted in, and all of that's kind of part of this private cloud compute, and it's offering a private cloud that's running the LLMs, but I don't think it's necessarily relevant. Yeah.
So this has been shared around a little bit because the bounties that Apple is paying out are pretty high. So for like arbitrary code execution with arbitrary entitlements, they have $1 million bounty. Even below that, they have uh, like bounties in the hundreds of thousands for lesser attacks. So if you're looking for a target, a particularly hardened target, could be something to look at. It is kind of cool that the code was published. That's not super common with Apple. The licensing is ridiculous on it, but the code is still actually open so that you can actually read it, and you don't have to do a bunch of reversing like you sometimes have to do with doing Apple research. So that's nice as well.
Yeah, mentioning the license here, I'm just going to pull up one of the licenses really quickly, or try to at least license. Have their own custom thing, but it is like Apple grants you for a period of 90 days from the day you download this. And of course, not exclusive. You can download, install, compile for like the 90 days. It is from the day you download. It seems like you could probably download it again in order to restart the license, but they're definitely taking a lot of steps here. So you cannot use this to like actually build your own product or something, but they do provide it out there so researchers can take a look at it, which I appreciate. I appreciate they made some attempt at doing that. It feels like a very silly license, but I kind of get what they're going for. On the bounty front, this does feel a little bit like, the Google Titan bounty, where they also have, I think, $1 million bounty on being able to break Google Titan, which is their like secure enclave system sort of deal. I actually forget all the details on it, so I can't remember exactly how what the break was on there, but I think it was like code execution side there for the $1 million. So it kind of feels like that, where like it is a big bounty. It's going to be very hard to actually get there. But they did also release a lot of documentation in here too about like the private cloud compute. So they are really enabling research.
Yeah.
Like
And
unlike
that's really important for Apple because they have a lot of their own custom text stack, a lot of custom three-letter acronyms they typically use. It's very inaccessible to do Apple research typically unless you have that documentation. So that's awesome to see.
yeah, or unless you go on like the research or device program with the phones, but then that means, or did they change that now? I know it used to be the case where if you got access to like the research device, you weren't allowed to claim bounties. I'm not sure if that's still the case anymore, but I'm pretty sure that was
So
back when they were private.
I don't remember on that, but what I do remember is that the biggest problem with like the Apple researcher program was that it was really hard to get into it. They were really strict with actually giving people access. If you had ever done anything that like Apple didn't really like, forget about it. You're not getting in. So again, like it seems like Apple over time is becoming more and more open for security researchers. So yeah, it looks like a good step in that direction overall.
Yeah, and like on a whole, so I know like this private cloud computing, I think is a really interesting area for research too. 'Cause, I know Amazon, like AWS has like a platform for like encrypted VMs, I think.
Oh, what's that
They
called?
have
I
a
know what you're talking about.
yeah, it's definitely not very open for anybody to like really take a look at. It's a really annoying, like they have like literally their own hardware that you can run, like you can get an EC2 instance that does this. I am just trying to look it up here uh to see if I can get Nitro, AWS Nitro
Yep.
enclaves.
Yep, that's what it
Yeah,
is.
so like private, that's been on AWS actually for quite a while, but I don't think Google or really anybody else has offered anything similar to that, except for like the actual hardware, like the more normal, I guess, options. And those are a step towards a sort of private compute. So yeah, it's really interesting to see this coming out from Apple, and this is going to be a very new area of research in terms of what are you looking for here? How do you break this? Like, it's just one of those areas. I think if you wanted to kind of do like some novel research, this would be a good area to start looking at. And they're offering the bounties for it because this is a relatively new kind of technology even. I almost want to say, like, it's not new technology, like it's not like nobody's ever thought about this before, but
In the
it's very
context of the
open,
industry and everything, I would
and
say it's new.
it's a new offering. Well, I mean, it's not even an offering because it's not like we can like build our own, like run our own private cloud compute. They are just letting us kind of test their own, but it's an area that hasn't got a lot of access to do research on, I guess is the way I'd put it, and they're opening this up quite a bit, which is really awesome.
Yeah.
Or at least it seems to be. I will be honest and say, like, I have scanned some of this. I have not like tried to run the virtual research environment. Maybe it's like really stupid and there's something we're missing, but it seems really
I
cool.
mean, with
Like,
Apple's reputation, I doubt it. So,
yeah, I just mean like we're talking about this, but I haven't actually verified, so I could be mistaken. I just want to have that caveat there. So, if it comes out like there's some really stupid thing that we're recommending, then, or like talking so highly about, that we can couch my language a bit, I guess. But yeah, I don't know. It seems really cool. It would be an interesting area to do research in, and I appreciate how apparently open they're being with this, which I think is actually really important too, because like this is machine learning stuff, which we always kind of hear about the privacy concerns about it. This is Apple ultimately like trying to have a sort of privacy preserving access to machine learning, LM, and all of that, like all the AI stuff, while preserving privacy of their users. Like it's a fairly, I guess, noble goal too.
yeah. And yeah, that, like I've said, like Apple's always kind of had that reputation of trying to take that seriously, and they've always led the charge on leading edge security mitigations and everything on pretty much every angle. So it's not too surprising, but like you said, the openness is something that has been changing and is very nice. Because it was kind of a controversial thing with Apple for a while. So yeah, things are changing a little bit.
Yeah.
So we had that to shout out. Z, there was also a last minute ad that you had, so I'll let you cover that and then we'll wrap up the show.
Yeah, really quick last minute ad. Just this is just one of our shout outs where there's a bunch of background information in here. It's just a nice little read through. But this is from Quark's Lab, one of their interns. Looks like this might have just been Boyer's intern, just them. Had to double check that here. But basically they wrote a Bluetooth lower energy fuzzer against generic attribute protocol. Or well, attribute protocol ATT, generic attribute protocol GATT. So yeah, Bluetooth low energy GATT fuzzing. They wrote a fuzzer documenting it, plenty of background information about kind of their flow, their thoughts, all of that. So yeah, just a shout out. Did have some results out of it, but nothing that we're going to get into now. It's still perhaps worth a read if it's an interesting area to you.
All right. So as always, thanks goes out to everyone who tuned in. As Z mentioned, if you have any like favorite vulnerabilities or posts that talk about like methodology and finding vulnerabilities, we would love to hear them. Leave them in the interesting links channel in our Discord or in the comments or something, because that would be something that would be cool to do a little bit more coverage on. But yeah, other than that, we will see you next week.